Chapter 2 Calorimeter. At the end of this chapter, students should be able to A. Define heat capacity and 2. Specific heat capacity. B. Calculate heat change in a constant volume calorimeter or bomb calorimeter. C. Calculate heat change in a constant pressure calorimeter, also known as simple calorimeter. Calorimetry is the process of measuring the amount of heat released or absorbed during a chemical reaction. By knowing the change in heat, it can be determined whether or not a reaction is exothermic or endothermic. Calorimeter, a device for measuring the heat developed during a chemical reaction and for calculating the heat capacity of materials. There are two types of calorimeter. The first type is constant pressure calorimeter, also known as the simple calorimeter. It is made up of styrofoam cup to insulate the reaction mixture from the surrounding. It is assumed that no heat is lost to the surrounding. Heat released by the reaction is absorbed by solution and calorimeter. No heat enters or leaves. Constant volume calorimeter is also known as bomb calorimeter. Bomb is a metal container at the center of the calorimeter. Heat released by the reaction is absorbed by water surrounding the bomb and the calorimeter itself. The basic principle of calorimetry is the conservation of energy, in this case heat. Heat produced by the reaction is all absorbed by the calorimeter, assuming no heat is lost to the environment. Or in other words, amount of heat released is equal to the amount of heat absorbed by the calorimeter. Here are some terms that you need to know to understand calorimetry. Heat, energy that is transferred from one body to another as the result of a difference in temperature. If temperature of the two bodies is the same, there is no heat flow. Second, heat capacity is defined as the amount of heat to be supplied to a given mass of material to produce a unit change in its temperature. The SI unit of heat capacity is Joule per Kelvin. Specific heat capacity. Specific heat capacity is defined as the amount of heat required to change the temperature of 1 kilogram of a substance by 1 degree Celsius or 1 degree Kelvin. When answering problems related to simple calorimetry, there are three possible types of equation that can be used. The first is Q equals mc delta T. This equation, when the assumption is the amount of heat produced is equal to the amount of heat absorbed by the solution. In this case, it is assumed that the calorimeter is an insulator and do not absorb any heat. The second type of equation is Q equals C cal delta T. In this type of equation, the amount of heat produced by the reaction is assumed to be the same as the amount of heat absorbed by the calorimeter. In this case, the calorimeter is made up of water in this water or solution, and also the calorimeter itself. The third type of equation is Q equals C cal delta T plus mc delta T. So in this case, the amount of heat produced is equal to the amount of heat absorbed separately by the calorimeter and the solution. Two types of equations to consider in bomb calorimetry. The first one is Q equals C cal delta T, where the heat capacity of the calorimeter, C cal, is considered to include the water surrounding the bomb. However, another type of equation is Q equals C cal delta T plus mc delta T. Here, we consider the water surrounding the bomb and heat capacity of the calorimeter to be separate and are considered separately in the calculation.